When programming selection statements, we often come to a time where our decisions are based on more than one piece of data. In fact, it's quite frequent. Think about yourself. When you want to go outside and play soccer or something like that, you may make your decision on more than one thing. It might be like, I'm going to go play soccer, but only if the weather's nice and it's daytime. You're not going to go play at nighttime. You can't see the ball. You're not going to go play in a snowstorm because it's just ridiculous. So your decisions are often made on more than one thing. Oftentimes we have to do the same thing in our programs. So what I've shown you here is a very simple program that calculates the area of a rectangle using a subprogram, a function particularly. So we have a couple variables, length, width, and area. We retrieve the input from the user, so I have no idea what the user is going to type in. They could type in anything. It's going to use a parse double, so it's going to convert it into a double. And then down here, I call calcRecArea with the length and width that the user entered in. And then that result of that subprogram is then going to be stored in the area variable and displayed to the screen. So if we run the program, we see down at the bottom, let's put in a value of a length of 2.5 and a width of 2. We should end up with 5. And we do. So rectangleRecArea is exactly what we expect it to be. Looking in the function, the subprogram itself, we see it's a very simple function. We've created a recarea and I've defined it a value of -1. It doesn't really make a difference because it's being recalculated right here. So we just take the length and the width and then we return the full area. The problem is that there's not a lot of error management here in terms of dealing with the user. So if I run the program and the user accidentally puts in a value of -2.5 and then a value of 2, we end up with an area of -5, a physical impossibility for any rectangle. You cannot have a negative area. It just doesn't work. So how can we handle this in our programs? Well, we can start to use if statements. We could start to test the data that the user enters and say, we're only going to calculate your area if you give us good data. So for example, inside of calcRecArea, I might want to do something like this. Alright, I will calculate the area if both the length and the width are valid, which means they're both positive numbers. So I could say if rec length is greater than 0. If it's greater than 0, that's great, but I still need to check the width. So I need to do another if statement inside of here. If rec width is greater than 0, then we will calculate the rec area. So what you see here is something called nesting. If you've ever heard of a Russian nesting doll, it's where you start out with a bigger doll, you can open it up and inside there's a slightly smaller doll. Open that one, there's a slightly smaller doll, and so on and so forth till you get to a tiny, tiny little doll. Those are called Russian nesting dolls. Well, that's where the term nesting comes from. It's a smaller statement inside of a larger statement. Now what you see here, it sets up a system of priority. So for example, if rec length is greater than 0. Only if that is true will it even go inside and test the width. That means if the user enters a value of -2 for length, it's not even going to waste the time and go inside to check the width because it knows it already failed that. So there's no point in doing any further work. So this sets up a system of dependency. Great, that's fantastic. Of course, what if the width is the -1 and the length is the +1? Well, that means it's going to have to test them both, but that's the nature of the beast. We have to check everything. So this is a great system, and this nesting idea is going to be used a lot, and allows us to make sure that both are true in order to do the inner code. But this is kind of ugly. There's got to be a better way. Well, sometimes nesting is the only way. But we don't always want to go that route. Just as a side note, when you are nesting, you probably shouldn't go more than 3 or 4 layers deep. Now this is 2 layers deep. 3 or 4 layers, you start to get indented quite a bit, and the code becomes unreadable at that point. If you're going more than that in depth, you probably should try and rethink your design. Maybe there's something else you could do or another strategy you could pull. So how are we going to handle dealing with this? How are we going to handle simplifying this structure of this nesting into something a little bit more readable? Well, to do that, we're going to learn a couple more operators. So we've learned mathematical operators, we've learned comparison operators. Now we're going to learn some Boolean operators. Now, Boolean operators are operators that depend on Boolean data, trues and falses. And we're going to combine that data to produce more Boolean data, more trues and falses. So it's all logic based. So I'm going to go quickly over to OneNote here and delete what we have in here. And just on the side, I'm going to start to go through all the operators that we have to work with within Java. And there's only 3. The first operator we have is something called AND. And in Java, the symbol for AND is a double ampersand sign, that symbol right above your 7 key. So what this means is that all elements, so the result will be true, so it will result in true if all elements are true. So let's give an example. Let's make some basic assumptions here first. So assumptions. Let's assume we have a variable called x, which has a value 6, and a variable y, which has a value 3. So just as an example to this, let's say we have is x less than 10 and y greater than 1. So what does this result in? Let's take a look. Is x less than 10? Yeah, x is 6. Is y greater than 1? Yeah, y is 3. Both of those are true, so the result is true. Conversely, we could have wrote something like this. If is x less than 10 and y less than 1, that is actually going to result in a false. And the reason why it's going to result in a false is because they're both not true. X is less than 10. Yeah, that's true. But y has a value of 3. 3 is definitely not less than 1, so the result is false. So basically, an AND means all elements are true. So for example, I'm going to go out and play soccer if the weather is nice and it's daytime. If either one of those are not true, I'm not going outside to play soccer. So that's AND. The next operator we have, is OR. The symbol for that is a double vertical bar. That symbol can be found right above your Enter key. Just hold Shift when you hit that key. And this results in true if at least one element is true. So let's do a couple examples. If x is less than 10 or y is greater than 1. In this case, both elements are true, so it's going to result in a true. Again, let's do the other one. Is x less than 10 or y less than 1? Great. So x is less than 10, so that's true. Is y less than 1? No, it's not. But the rule for OR just means at least 1. That's all that matters. So for example, I have a ball and it's going to bounce if the ball is made out of rubber or the ground is made out of rubber. Either one or both, and I'm good to go. So this will result in a true as well. Very simple. The last Boolean operator we have is the exclamation mark, which means not. So this results in a true when the element is false. Basically, it gives us the opposite of whatever we have. So if we have a false, it results in a true. If we have a true, it results in a false. So we always get the opposite of whatever it is. So for example, I could say a statement like this. Not x equal y. Well, let's think about this. How does this result? Is x equal to y? Is 6 equal to 3? No, it's not. But the opposite of that gives us a true. So the opposite of false gives us a true. So this will result in a true statement. I know this stuff can be fairly complicated, but what it does allow us to do is create a system like this. We can now test two values at the same time and only do something if both are true. So if we go back to our example in Eclipse, instead of having this ugly code here, we can rewrite this into the following. We could just say if rec length is greater than 0 and rec width is greater than 0, we are going to calculate rec area. Rec area is equal to rec length times rec width. So that is much more clean and easier to read. So it's one of the reasons why we would use compound, or why we would use Boolean operators. Sorry, I got ahead of myself there. When we use these statements and use these ands and ors, this is called a compound if statement. It means that there's multiple comparisons done in a single statement. What I want to emphasize is that these are actually fully complete statements. So if I could break them off and make individual statements as I did up here with them. What I can't do, some people will get ahead of themselves and they might want to say, hey, if x is greater than 1 and less than 10, because they want to write it the way they speak. You can't do that. You have to have two complete statements. You have to have is x greater than 1 and x less than 10. It must be fully complete in order to be a valid syntactical compound if statement. So these are how we handle Boolean operations, how we combine into complicated statements that will allow us to be more flexible within our decision making. Next modules are going to cover how to make more than two choices and really give us some flexibility within our programs.